Okay, for this next part of geometry, two-dimensional geometry, it's going to be some review given what we've already done this year when we did geometric probability, as well as what you have learned last year and in years prior. We are not going to have to make this a fraction or a percent. All we have to do is figure out what is the area of the shaded region. So inscribed figures are going to mean that there's a hole in the middle. And therefore, we are going to have to subtract. So anytime you have two figures, one inside of the other, it's not all shaded, we're going to end up having to subtract them. So let's take a look at this first one. If we notice there's a square on the outside, there's a square on the inside, and there's a shaded region. So to do the square on the outside, we have to note that one side of the square is 8 inches, and since it's a square, we know that the other side is 8 inches. Therefore, it is 64 inches squared because it's going to be 8 times 8. So then we take a look at the smaller square on the inside. And we note that one side is 4, and since we know that it's a square, we know the other side is 4. Area of a square is 4 times 4. We end up with 16 inches squared. Now, in order for us to figure out how much all of this is around the outside, we have to subtract the outside shape minus the inside shape, leaving us with 48 inches squared shaded. Let's go through that same process for this one. When we look at it, we should note that we end up having a rectangle on the outside, and then we have a semicircle on the inside, and then we have a region or an area that's shaded. So first we have to deal with the outside shape. And if we notice, we have one side is 13, one side is 9. Therefore, to do the outside, we would do 13 times 9 because the area of a rectangle is length times width, and we get 117 meters squared. Then we look on the inside, and we notice that we have a semicircle, and that the diameter is equal to 7. Well, we know that area of a circle is pi times radius, or pi r squared. So we would do 3.14 times r is going to be 7, the diameter, divided by 2, which is 3.5. So we do 3.14 times 3.5 times 3.5. However, we're dealing with half a circle, meaning we have to take that whole area and divide it in half. And we end up with 19.2325. And then to do the shaded area, we take our outside area of 117 meters squared and we subtract that hole that we cut out, which is 19.2325. And we end up with 97.7675 meters squared. Now we come to the last shape. And we should note that we have a square on the outside, and we know it's a square because both sides are the same length. Then we have to think, what shape do we have on the inside? Well, if we look at it, we notice that we end up with curved edges. Hopefully you remember this from when we did probability. But we have a circle because those 4 corners represent the fourths of a circle, and together they make a full circle. And then, of course, we have the shaded area inside. So outside, we have a square that measures 24 times 24, and we know area of a square is length times width, so the total area is 576 feet squared. And then we know on the inside that if we were to take all of these pieces together, those 4 pieces, and we were to rotate them 180 degrees, they would end up forming a circle. So we know area of a circle is pi r squared. So we do 3.14 times 12 squared, or times 12 times 12, and we get 452.16 feet squared. And to do the shaded region, we have to take our outside figure area, which is 576, and we're going to take away the holes that we cut out, the 452.16 feet squared. That leaves us with 123.84 feet squared. Now we're going to take a look at composite figures. And composite figures is when you put 2 figures together, meaning that we're going to have to add on this because it's all going to be shaded or it's all put together. And that pretty much what we have to do is find the area for each and then we put them together because that's what we did with the 2 figures. So when looking at this first one, we should note that it is like they have gone and taken a triangle and added half a circle onto the end of it. By drawing that line across, I've divided it up into the 2 shapes. So when we look at this, we note that we have a triangle, we have a semicircle, and then we're going to have a total area. So again, I have 2 shapes just like we did with inscribed figures, and so we have to do the area of both. So the first one we're going to do is the triangle because that's the easy one. And we know that the triangle measures 9 this way, but when we look at it this way, we can't just say 4 because 4 only represents this part. We have to note that over here on the semicircle, it's got a radius of 3, meaning that side is 3, but so is that side. Therefore, our base of our triangle is 3 plus 3 plus 4, which means the base of our triangle is 10 inches. So to find the area for the triangle, we would do 9 times 10 and divide by 2 since it's a triangle to get 45 inches. Now we need to take a look at the semicircle. So we know that area of a circle is pi r squared because Fuzzy Wuzzy was a bear and area of a circle is pi r squared. So we're going to do 3.14 times our radius is 3 times 3 times 3, and we end up with 14. Oh, sorry. And then we have to divide that by 2 because it's a semicircle, and we end up with 14.13 inches squared. So to find the total, we have to add the triangle's area plus the semicircle's area, and we end up with 59.13 inches squared as the total area for the composite figure. For this last example, we are asked to find the area for the entire figure. We do this by finding the area for each of the 3 rectangles and then adding them together. The first one's going to be this rectangle. For this rectangle, we would multiply length times width. Therefore, this one would be 7 times 18, which gives us 126 meters squared. For this one, we would do 10 times 8, which is going to give us 80 meters squared. Those are the 2 easy ones because their dimensions are really easy to see.
Speeds up to 45 megs for $30 a month.
The more difficult one is this middle rectangle, because we're not really told either of the dimensions. We have to figure out what is the length and what is the height for that figure. Now, or what is the length and what is the width. To figure out the short side, we know that the whole figure is 22, and we know this because of the bottom number, at the very bottom. We also know that the rectangle on the left has a short side that's 7, and a rectangle on the right has a short side that measures 10. And that tells us that that leaves 5 meters for the short side. So we know 5 is the short side. For the long side, we know that the entire height or length or width or whatever the long side dimension you want to use is 18 because of the tall rectangle on the left. And we know that there's a little bit of that rectangle that measures 2. That leaves us with 16 meters for the long side of that middle rectangle. So to do the middle rectangle, we would say 5 times 16, which is 80 meters squared. To find the total area, we must add 126 plus 80 plus 80, giving us a total of 286 meters squared.